Welcome everyone to our 9th place solution presentation to this year's SIIM-FISABIO-RSNA COVID-19 detection prediction. And this is the presentation of Team Watercooled. My name is Philip. I currently work as a senior data scientist at H2O. I have a PhD in computer science, quite some experience in research, and I'm currently top ranked Kaggle, and meaning I have quite some experience on Kaggle.
Hi, I'm Christoph. I work as a deep learning data scientist at NVIDIA. My background is in mathematics, where I did a PhD. I co-authored multiple machine learning papers, and I'm currently number 2 on Kaggle.
Hi, I'm Pascal. I'm a software engineer in the field of automated driving. I have a PhD in electrical engineering at RWTH Aachen, and I'm currently ranked 5th in the Kaggle leaderboard, meaning I'm also quite experienced. In this challenge, we had to identify and localize COVID-19 abnormalities on chest radiographs. That means for once we had to classify between 4 different classes, and we also had to detect the correct position of the abnormalities. The metric was a mean average precision metric, and we had a very small training sample of just a few more than 6,000 samples. Our pre-processing was mainly due to computational constraints. So we converted the DCOM images to PNGs and scaled the width and height by a factor of 0.25 and 0.5. We followed the advice of the hosts for the handle of the duplicates in the image level and removed all images that had no bounding boxes, where we also had bounding boxes. Our cross-validation, for our cross-validation, we did a 5-fold on study level, and we trained separate models for the study and the image detection.
Yeah, for the classification part, we used efficient net backbones and cross-covariance transformer, which is quite new, newly released from Facebook. We added an extra loss, namely the segmentation loss for the boxes, to help regularize our models. And for the classification, we used the softmax layer. At the end, we had 9 classification models, each trained with 5 folds. For the detection part, we have an ensemble of YOLO v5 and efficient net based backbones. We mainly used a single class, namely the opacity, so the occurrence of box, but we also trained one model where we added a virtual box representing the whole image, which was representing the none prediction. At the end, we had 8 models, also each trained with 5 folds. For post-processing, we found 2 simple things that worked quite well. We took a simple mean of no bounding box predictions and the negative class. And for the no bounding box prediction, we took an weighted average, where we used 0.5 times 1 minus the maximum box confidence, plus 0.5 times the negative class, plus 0.2 times the atypical class. Our classification models were ensembled with a simple average after the softmax layer. And for the boxes, we predicted at max 25 boxes per model, and then blended with weighted boxes fusion at an IOU of 0.5.
Yeah, one more note on hybrid models. So as you could see in our solution, we trained separate classification and detection models. But in the beginning specifically, we also saw that models directly predicting both parts at the same time can work really well. So what you do is that you take the same backbone, for example, for efficient net and the classification part. And this might lead to a more streamlined solution that can potentially be preferred in a deployment scenario. So yeah, this is just to show that this solution could also really have merit in production. Regarding external data, our solution does not use any external data. We only rely on the around 6,000 training images. But we saw from other solution descriptions that external data holds some potential improvements. So in the future, if we would want to continue working on this problem, we would aim at investigating this further to potentially further improve the solution presented. In the end, as already hinted towards in the beginning, we ended 9th, actually both in the public leaderboard and in the private leaderboard, meaning we had a really stable solution with no big surprises. And yeah. This leads us already to the end of this presentation. In case of any further inquiries or just to follow us for further updates, please check out our Twitter. Thank you.
Thank you.